Swayam Prabha. Digital India. Educated India.
Welcome friends to this new lecture of environmental soil chemistry, and this is the second lecture of week 1, and in the first lecture of environmental soil chemistry we tried to give you some overview of this course, and we discussed what is soil chemistry and what is the difference between soil chemistry and environmental soil chemistry. Remember, this environmental soil chemistry basically deals with different types of environmental issues which are related to both soil and water, and in our first lecture we discuss the definition as well as we briefly discuss the evaluation of this branch of soil chemistry, that is the environmental soil chemistry, how this branch was affected by enactment of different types of laws which specially initiated in United States, and what was different implication of those laws. Then we talked about what are the different kinds of pollutants which are mainly responsible for soil and water pollution. We started with some nutrients, specifically nitrogen and phosphorus, and because they basically create eutrophication of lake and water bodies. And then we talked about the different sources of water pollution. We talked about point source of pollution, we talked about non-point source of pollution, and what are the different non-point pollution sources, what are the different types of point source pollution sources. So, we discuss all of these. We discuss different interaction between different point source and non-point source pollution sources, and then we talked about the fertilizer consumptions, especially the changes in fertilizer consumption in developed countries as well as in India. And in today's lecture we will be discussing about other environmental pollutants which are responsible for soil and water pollution due to their indiscriminate uses, and mainly we will cover different pesticides. Overview, we will give you some overview of the pesticides which are responsible for environmental contamination, and then we will talk about trace elements which are also very important source of environmental pollution, and then we will talk about some methods which we generally employ for remediation of soil and water contamination. So, let us start with these pesticides. If you see here, the pesticide is very important groups of chemicals, and this pesticide can be classified into 4 to 5 different subclasses. For example, we can herbicides which are basically used for controlling the weeds. Secondly, insecticides which basically use for controlling the insects. Then fungicides which are required for controlling the fungi and fungal infection, and then nematicides which are required for controlling the nematodes, and rodenticides which are responsible for controlling the rodents. So, all these are important classes of pesticides, and based on their specific target group, they have been classified into different names. So, remember that the pesticides were first used in agricultural production in the second half of the 19th century, and especially some examples included lead, arsenic, copper and zinc salts, and naturally produced plant compounds such as nicotine. So, all these elements like leads, arsenic, copper and zinc salts, all they have insecticidal properties, And this nicotine, which we nowadays know, this is present in tobacco, this is also this nicotine also has high insecticidal properties. So, in the second half of 19th century, when people started using different types of pesticides, they actually used these different types of salts as well as nicotine. Now, in the 1930s and 1940s, 2,4-D, which is the short form of 2,4-dichlorophenoxyacetic acid, and which was basically herbicide, and another insecticides called DDT, which is the short form of diphenyl trichloroethane. As you can see in this slide, both of them, I have presented the structure of both these chemicals. So, this 2,4-D is an herbicide, and this DDT is an basically insecticides were basically introduced in 1930s and 1940s, which are highly effective for controlling these different types of weeds as well as different types of insects. Now, the benefits of this pesticide have played an increasing crop production at a reasonable costs are obviously unquestioned. So, there is no question that while introducing these new pesticides in 1930s and 1940s, they hugely contributed for controlling the pest and weeds to increase the agricultural production. However, as the time goes on, as the time went, the indiscriminate uses of these herbicides and pesticides have contaminated the soil and water and created a huge impact on the environment. So, that is why in most of the countries DDT is now banned because of its high environmental residual impact. So, the total pesticide, if you see, the total pesticide use in United States has stayed constant about 409 million kgs per year after increasing significantly through the mid 70s due to greater herbicide use. And so, the the use of herbicides have continuously increased after 1970s. Initially, there was mainly insecticides. However, from 1970s there has been a continuous increase in herbicide application both in US and other countries as well as in India, which we will see later. And as a result, that there is the application of insecticides was kind of stayed constant in United States. Remember that agriculture accounts for 70 to 80% of the pesticide use, and about 60% of the agricultural use of pesticide involves herbicides applications, because weed is a very important issue nowadays for agricultural production. In this regard, we want to discuss one important law proposed by this USGS 1999 USGS. So, that is called Water Quality Assessment, that is NAWQA program, which basically takes into account the problem of pesticide based pollution of soil and water. So, it is one of the most recent and comprehensive assessment of water quality in the United States, and that has been conducted by the USGS. So, if you see the pesticide consumption in USA, this plot gives you some indication of how the use of different pesticides and herbicides changes over the time. So, you can see from 1964 to 1996, there has been a continuous increase in application of herbicides in agriculture, as well as there has been a continuous increase in total pesticide used in agriculture, and also cumulatively the total use of pesticides also continuously increased up to 1980s, and then suddenly it decreased a little bit, and then reaches a plateau around 1992 and in 1990s. However, the total organochlorine insecticides, especially the DDT and other organochlorine insecticides, which are highly important environmental pollutant, their use have been continuously diminished because of increased environmental concerns. So, as you can see, the application of total organochlorine insecticide used in agriculture was continuously decreased because of their environmental impact. whether while the use of pesticides, especially the herbicides, have continuously increased and then reached a plateau. So, if you see the relative level of contamination in streams and shallow groundwater from different sources, in different areas like urban areas, agricultural areas and undeveloped areas, you will see that nitrogen produces medium level of contamination in urban areas, whereas it produces medium to high level of contamination in the agricultural areas because of nitrogenous fertilizers use. And in case of undeveloped areas, obviously there is no significant effect of nitrogen contamination. In case of phosphorus, the similar phosphorus in both urban and agricultural areas, we get medium to high level of contamination, whereas in undeveloped areas there is again low level of contamination. In case of herbicides, obviously agricultural areas, due to huge application of herbicides, produces low to high amount of contamination in agricultural areas. However, since the application of herbicides is limited in urban areas, the hazard from the herbicide application is been somewhat medium in case of urban areas. However, we did not have any data for its application and hazards in undeveloped areas. Currently used insecticides, if you think about the currently used insecticides, obviously it produces medium to high level of contamination in urban areas, whereas it produces low to medium level of contamination in the agricultural areas, whereas there is no data available for undeveloped areas. And in case of historically used insecticides, obviously in urban areas it produces medium to high level of contamination, because these DDTs and all these things were basically used for controlling other insects which are present in urban areas. Agricultural areas also produce low to high contamination. However, in case of undeveloped area, it produces low amount of impact. So, if you can see in a nutshell, in the streams of these urban areas and agricultural areas, it produces medium to high level of contamination from all of these sources, starting from first nitrogen, phosphorus, then herbicides, currently used in insecticides as well as historically used insecticides. So, both these urban areas and agricultural areas were known to be impacted by the use of different types of herbicides, insecticides as well as sources of eutrophication. However, if we consider the shallow groundwater in urban areas and agricultural areas, nitrogen creates medium problem in case of urban areas. However, it produces high contamination in agricultural areas because of use of nitrogenous fertilizer, indiscriminate use of nitrogenous fertilizer. In case of phosphorus, we did not see any any substantial contamination. In case of herbicides, where it in urban condition it produces medium level of contamination in case of shallow groundwater. However, in case of agricultural areas, they produces medium to high level of contamination. Currently used insecticides, it produces low to medium in both these conditions. However, in case of historically used insecticides, it produces low to high in both these conditions. So, if we can see, if we can consider the shallow groundwater, nitrogen produces stark differences between the urban areas and agricultural areas because of shallow water nitrogen contamination due to indiscriminate use of nitrogenous fertilizers. However, in case of insecticides and in case of insecticides, both urban areas as well as agricultural areas, shallow groundwater produces almost similar level of contamination. So, if we want to see the levels of nitrates in shallow groundwater in different parts of US, this map gives a better indication. So, you can see in several parts of US, the nitrogen nitrate in shallow groundwater exceeded the background concentration. For example, these red dots specifically surrounded, and these yellow dots surrounded by these bold outline basically indicates the median values in these areas exceeded the local background concentration, which is considered as a reference value. And so, these trends can be seen in these eastern parts of United States as well as some western parts of United States. And so, the southern parts of United States is not highly showing these nitrate contamination. So, but however, some medium level of contamination is all is present in the mid United States. So, basically that shows the distribution of pollution of nitrate in shallow groundwater, and and in which areas the concentration increases beyond their background concentration. So, if we also see the frequently detected pesticides in water of agricultural and urban areas, some important trends are there. So, we can see here, for example, let us consider this agricultural land and then urban land and then major rivers and the aquifers. And if we consider this, so obviously frequency of detection of different types of pesticide, if we consider, you will see that atrazine is highly detected. The frequency of atrazine detection is high in case of both major rivers and aquifers as well as in urban land and agricultural lands, followed by these metolachlor and other pesticides. And in case of and also we can see the simagins and then prometron, all these things are also highly prevalent in both major rivers as well as in urban land and agricultural lands. So, obviously, in case if we consider the agricultural lands, the occurrence of this atrazine is high, which is a important pesticide, and in case of urban land also we can see the high occurrence of atrazine and then simagin and prometron, and in case of major rivers obviously again the atrazine. So, that says that says that atrazine is one of the most important pesticides which has shown increase level of their occurrence in different areas, be it in agricultural land, it may be in urban land, or it may be in the rivers and other aquifers. So, if you see the pesticide consumption trend in India, obviously from the this plot shows the data from 2000 to 2001 to 2016-17. So, you can see there has been some some increase in pesticide consumption from 2000 to 2016. So, almost in 2014-15 and 16-17 the consumption was almost same. So, but there has been an increase from pesticide consumption from 2000 to 2016-17 obviously. Also the consumption per hectare also increased and reached a plateau in 2014, and so that gives you an that gives an indication of how these pesticide consumption increase in case of Indian farms. However, so if you see the pesticide consumption in India in different states, so one important some important trends you can see here. First of all, if you consider the latest data of 2015-16, you will see that the total consumption is highest in Maharashtra, followed by obviously Uttar Pradesh, and then followed by Punjab and other states. So, the consumption of pesticide, one of the reason of high consumption of pesticide in Maharashtra is the cotton cultivation, and cotton requires a huge amount of pesticide application. So, that is probably one of the major reason for high pesticide consumption in Maharashtra and followed by Uttar Pradesh and Punjab. So, this basically gives you an indication of how different states are using huge amount of pesticide for agricultural sector. So, if we go ahead and see the pesticide, another pesticide consumption trend, that means how the share of different classes of pesticides has changed along the across the time. So, from 2003 to 2004 and then 2016-17, one trend is very apparent. First of all, as I have already told you, that the consumption of insecticide has continuously decreased, and the consumption of fungicides and herbicides and rodenticides showed increment. So, there has been a continuous trend of decreased use of insecticides. However, the other classes of insecticides, other classes of pesticides like fungicides, herbicides and rodenticides, due to increased awareness of their specific use, their use have been continuously increased. So, if you see the pesticide trade scenario in India, obviously India export huge quantity of fungicides, about 174,000 tons, and followed by herbicides, and then also it exports huge amount of insecticides. However, it also imports different types of pesticides, like 16,000 tons of herbicides, 8,000 tons of fungicides and 18,000 tons of different insecticides. As far as the plant growth regulator is concerned, India export very little amount, only 2,000 tons of plant growth regulator. However, they import 11,000 tons of plant growth regulators for their use. So, if you see the countries in which India mainly export the different types of pesticides, and also the countries from which they import this pesticide, you see some trends here. For example, as far as the export is concerned, the major destination for export for Indian insecticide, fungicides and herbicides are Brazil and also USA. However, in case of France, they have only export the different types of fungicides. In case of importing different types of pesticide, China is the major source of import of different insecticides, fungicides as well as herbicides, and also India import insecticides from Germany and also fungicides from Germany. However, from Japan and Israel, they import different types of herbicides. So, that shows the also different types of bilateral trades as far as the different types of classes of pesticides are concerned from India. So, that gives a overview of pesticides, different types of classes of pesticides, their consumption their consumption trends, and consumption trends both in United States as well as in India, and due to their increased use in agricultural sector as well as in other parts of urban environment, they are one of the major sources of environmental pollutant, and that is why pesticides have got increased importance nowadays whenever environmental soil chemistry is discussed. So, another important aspect of environmental pollution is acid deposition, and remember, this acid rain is another name of this acid deposition. So, acid rain refers to this deposition of acidic components in either wet or dry forms, either it could be in particulate forms or in terms of rain. So, it is basically defined by a pH of the liquid which is generally less than 7 in case of acidic, and more than 7 is basically basic, we know that. So, natural acidic rain which can be caused by different types of volcanic emissions and different types of biological processes. And remember that in case of rain, which is basically we consider as a clean rain, which is a natural acid, it produces a natural acidity of 5.2 on the pH scale, because these acidity is produced because of the presence of carbonic acid. And now you can ask me how this carbonic acid is formed. So, basically when the water reacts with the carbon dioxide which is present in the atmosphere, they produces to form this carbonic acid, which is a mild acid, and as a result that this clean rain has a acidity of 5.2. So, this is how this carbonic acid is basically formed, as you can see, which is water when it reacts with the carbon dioxide produces H2CO3 or carbonic acid, and this carbonic acid further reacts with the water to produce these carbonate ions as well as these hydronium ions. Now, acid deposition or acid rain basically results from the burning of fossil fuels such as coal, which generate different types of sulfur dioxide as well as nitrogen oxides, and from exhaust of motor vehicles, which is a major source of nitrogen oxide. So, all these burning of fossil fuels and exhaust from these automobiles produces these gases, specifically sulfur dioxide and nitrogen oxides, which basically reacts with the water vapor which is present in the atmosphere to produce different types of nitric as well as sulfuric acids that are often carried for long distance by wind and then fall to the earth via precipitation such as rain, snow, sleet, mist and fog. So, as you can see here, burning of coal, which is another major source of these sulfur dioxides and these gases basically reacts with the water vapor to basically produce the acid rain. So, this picture gives you a more comprehensive idea of this acid deposition. As you can see from here, obviously burning of the fossil fuels produces this nitrogen nitrogen oxides. However, then burning of fossil fuels also produces this sulfur dioxide and NOx, which ultimately goes to the atmosphere and mixes with the water vapor to produce the sulfuric acid and nitric acid, which can either produce dry deposition in in the form of particulates or gases, or it can produce the wet deposition in the form of rain, snow and sleet. So, this is the total process of the acid rain. Now, what human has to play in this whole process of acid rain? Well, human effects are very important while while considering this acid rain, because human emissions of sulfur dioxides and nitrogen oxides contribute to the acidification of the rain, because whatever the sulfur dioxide and nitrogen oxides generate into the atmosphere due to different types of burning of fossil fuels, these are all anthropogenic processes. Now, emission began during the industrial revolutions, remaining unchecked until the 1970s. So, during the industrial area, during the industrial era, basically different countries, both developed and developing countries, produces huge amount of these industrial emissions, which remain unchecked until 1970s. So, the biggest contributor, remember the biggest contributor is the burning of the coal, and annually, remember, 70 teragrams of sulfur emissions comes from burning fossil fuels, whereas compared to the only 8 teragrams from volcanoes and 2.8 teragrams for wildfires. So, that shows the overall impact of anthropogenic effects in producing the acid rain, and that is why it is very important to control these different sources of producing acid rains for safeguarding our environment. So, friends, so far we have talked about different subclasses of pesticides, as well as their specific uses and their consumption trends in developing countries as well as in India, and how their application have been changed across the years for last 30 to 40 years, and what is the acid rain and how different human or anthropogenic activities affects these the production of these acid rains. So, I hope that you have gained some important information through this lecture, and let us continue from here in the next lecture. Thank you very much.